So the purpose of this video is to give you an example of an EFA CFA comparison and to give you some background on the data that you are going to be playing with, which is a subset of my dissertation. The numbers may not be exact match to this presentation. I have multiple data sets, depends on which one you end up playing with. So we first have to start with what is the concept that we are trying to measure. And for this, I'm trying to do three things really, but I'm trying to understand teachers' knowledge and use of data and assessments, because if we just are constantly doing professional development and we don't know where teachers are starting from, we're wasting our time. And this is really all about the assessment process. And so there's kind of 6 things that happen within this assessment process. You set a goal, you communicate the goal to students, you choose an assessment strategy to measure the goal, you analyze and use the information from the assessment, you give students feedback on what and how to improve, and then you reflect on and advise your instruction. This can happen over the course of a unit. This can happen over a single lesson. This can happen in a classroom within 2 minutes of me setting something, talking about something, realizing based on facial expressions and some formative assessments you have no idea what I'm talking about. There's my analysis, giving feedback, saying to myself, we got to stop, reflect, start over. All of this can happen very, very quickly, or it can be over a long process, depending on what kind of assessment strategy I'm using and how I'm analyzing the information. So there ends up being 3 parts to the TCUDA, the teacher's knowledge and use of data and assessments. The knowledge items say, I know how to set learning goals, I know how to communicate learning goals, I know how to choose assessment strategies, etc. And then the use items are a frequency matched to these. So I set learning goals, how often? I communicate learning goals, how often? And then there's this practical applications, which we are not using because it's not a true scale, but it's trying to see, I do something and I use certain sources of data. That way we can capture what are the assessment strategies you're using and how are you using that information. But you won't see that. So when we think about reliability to start, both of these scales, knowledge and use, are very reliable. Validity was established in a lot of different ways. Content validity with expert reviews, cognitive interviews, and also the correlation with Roche-Logit positions was very strong, considering how experts rated difficulty and how the Roche model actually put difficulty. I did convergent and divergent validity with 2 similar scales, and we can see that use matches the use and knowledge diverges from the knowledge factors from those items and those scales. Credibility is something that is not normally done, but I had a very unique opportunity. You can read more about that in my dissertation if you want to. So adding some kind of qualitative validity. Construct validity was done with Roche scale statistics. Internal structure was done through EFA item analysis, specifically using principal components analysis, Roche dimensionality, and of course Roche diff. This presentation is only focused on the EFA CFA, and we do a split sample for these because in classical test theory results are sample specific, so it is inappropriate, wrong, makes no sense to use the same data set for an exploratory factor analysis to explore the correlation patterns and then use the same data set for a CFA, because all you're doing in that case is confirming the correlation patterns that you found in the EFA. That's not what we want. We want 2 different samples that are completely independent of each other to see, does the conceptual model hold between 2 different samples. So that's why we do the split sample. We can see use has 1 strong factor, maybe a tiny, tiny secondary factor. Sorry, that was knowledge. Use, we can see 1 major factor, and then the elbow is much higher. We have potentially 3 other things here. So let's look at this a little deeper. With knowledge, for the exploratory factor analysis, we are seeing 1 overarching factor with a huge eigenvalue, and maybe a small secondary factor. The Vermax rotation, looked at the 2 factors, and we do see that that second factor are the two items that are about disaggregating data. They're about analyzing data. So it kind of makes sense as a second factor, but when we force one factor, everything does load onto the single factor above a 0.58, and the parallel analysis does support a single factor. For use, we see one primary factor and then three possible small factors. Parallel analysis also indicates or supports one factor, meaning these other three might be chance. When we look at the item loadings in the unrotated matrix, everything does load above a 0.4, so maybe that's a single factor. The problem is that when we look at the rotated matrix, the items that load on these three sub-factors make logical sense. So we could kind of talk about them as a single factor, but it does make sense that there's four factors within this. So for the CFA, with a new sample, we're going to try 2 models for knowledge and 2 models for use. So we can see here, I'm pulling out the 2 items about analysis. And what we find is that the single factor doesn't fit super well. Even removing items that misfit, we can get an improved model fit, but it's not great. The 2-factor model is an improvement, and especially when removing the misfit items, we're in a much better place, at least with a CFI. Still not perfect, but closer. For use, we're going to run 4 factors and compare that to a single factor. For the single factor, it's not good. Neither one of these are good. And even removing items that misfit due to 4-factor loadings, it doesn't improve. 4-factor, major improvement, and especially when removing item 2 that was still misfitting, we get an even better fit. So much more support for a 4-factor than a 1-factor. So dimensionality still has to be thought of holistically. So the EFA for knowledge is supporting 1 dominant, maybe another minor. Parallel analysis is supporting 1 factor. Roche supported 1 factor, but the 2 analysis items did misfit and had to be removed. And the CFA is supporting 2 factors with that analysis group. I like unidimensional, so I'm going to kind of force this into a unidimensional aspect, keeping an eye on those 2 misfit items for the moment. For use, a lot more needs to be done to really explore this, because we seem to have conflicting views of 1 factor and 4 factors. Roche actually supported a 1 factor, even though there were 4 items that misfit. They were not 4 items, they were just random. They weren't the 4 factors. So I kind of am saying this could be unidimensional, but there do seem to be some facets within here. And specifically, we need to note items of concern, because they're not concern on everything. And so item 2, for example, was a concern with Roche and CFA, but was fine for EFA. Item 9 was a problem for the principal components analysis, EFA, and Roche, but was fine for CFA. So we have some things that need to be kind of considered. Not everything is perfect on every kind of analysis that we're doing. You are welcome to email me questions, especially as you start playing with this data.